at early stages. Strength enhancement. Crack control. This is with regard to shrinkage reduction. To improve pump ability, finish enhancement, early strength and reduce permeability, meaning the seepage, okay, the seepage of certain liquid to your concrete. Produce a fluid backfill which flows easily and is self-leveling. Okay, Mr. Tined, please mute your microphone. Okay, to reduce the total cost of the materials used in concrete. Okay, if you're going to reduce it, I mean, if you want to reduce the cost, because concrete is actually, I mean, cement is of course very expensive, you may opt to use additives and admixture, or admixture, I should say. The type of admixture that you're going to add, we have what you call the plasticizers. This is water reducing agent. When concrete of high workability without using excess of water is required, then plasticizers is used. The main types of plasticizers are the lignosulfates based, the melamine sulfate based, and the naphthalene sulfate based. So take note of the types of plasticizers that you are going to use, whether it is for plasticizers or for super plasticizers. So for super plasticizers, we have what you call the high range water reducers. The use of plasticizer is practiced for production of flowing, self-leveling, self-compacting, and for the production of high-strength concrete and high-performance concrete. So take note what specific admixture you are going to add for a specific application. Superplasticizer are chemicals, compounds such as modified lingosulfates, sulfonated melamine formaldehyde, sulfonated naphthalene formaldehyde, and other polycarboxylate-based materials. Okay, so do you have corresponding types for plasticizers and superplasticizers? Other types of admixtures are retarders. So what are the uses of these retarders? They are used when delay in setting time is required to ensure sufficient placement, vibration, or compaction. Meaning to say, if you are going to delay the setting time or the curing time, let's say you are going to add some more of your concrete, let's say you have to make use of a design wherein your concrete is to be applied in a curve mature manner, mayroon kang design, you have to delay the setting time. So you are going to add retarders. Commonly known retarders are calcium sulfate, hydroxylated carboxylic acids, sugars, acids, or salts of acids. Now, accelerators are the opposite of retarders. So sa accelerators naman, they work by accelerating cement hydration, which results in shortened setting times and increased early age strengths, particularly in cooler temperatures. Our example here is calcium chloride as an accelerator, meaning if you want to set or you want to have your concrete having a faster drying time or curing time, you should add accelerators, especially for uh, areas or places or what you call in countries having a cooler temperature like winter season or what you call yung may mga malamig na panahon. you have to add accelerators para mas mabilis na mag-set or mas mabilis mag-cure yung concrete mo. So what are the types of concrete used in pavement construction? We have the high-strength concrete, high-performance concrete. We have the stump concrete, fiber-reinforced concrete, and self-compacting concrete. Although we can also use the standard concrete for pavement construction. So specifically, we will be taking each one and identify what is suited, what type of concrete is suited for pavement construction. For high strength concrete, it has a compressive strength greater than 40 megapascal or 600,000 pounds per square inch. Okay, this is the compressive strength that it can withstand. Now, recently, this strength has rose to 50 to 60 megapascal. And its use has increased in construction of high-rise building and long-span bridges. The high-strength concrete is made by lowering the weight to compressive strength ratio to 0.35 or lower. In design, no, in engineering design, they have to consider all of this. Often, silica fume is added to prevent the formation of free calcium hydroxide crystals in the cement mix, which reduce the strength at the cement aggregate band. So, pag sinabing the formation of free calcium hydroxide crystals, saan manggagaling tong free calcium hydroxide na ito? Where will these free calcium hydroxide crystals come from? Class, saan manggagaling?
Di ba ma'am yung accelerator, ma'am, may ganun po ma'am, na ang tawag dito?
Calcium,
Parang naman, yun nilalaman ma'am.
calcium chloride yun.
Calcium chloride po.
Calcium hydroxide. I'm talking about calcium hydroxide. I mentioned this during the beginning of the discussion of concrete. Actually, sa start pa lang ng cement and concrete. Recall. Recite kayo para may additional points. Saan nanggagaling yung calcium hydroxide na pwedeng mag-crystallize? That's why they are going to add silica fume. Okay, let me ask you, what are the components or the composition of cement? Actually, cement consists, one of the composition of cement is 0.5 to 1.5 free lime. What is free lime? That is free calcium hydroxide. Lime is actually calcium hydroxide. Okay, take note of that. Okay, so pag nag-crystallize si calcium hydroxide, it will reduce the strength of your cement aggregate band. To avoid that, mag-a-add sila ng silica fume. Okay, low weight to compressive strength ratios are and use of silica fume make concrete less workable. So in order for it to become more workable, this is true, for high performance or high strength concrete, they are going to reduce, or I mean to say, they are going to apply more dense rebar. Okay? More rebar should be applied in order to increase the workability of your high strength concrete. Again, to compensate for reduced workability, steel superplasticizers are commonly added. Okay? For the reduced workability, superplasticizers are to be added for your high-strength concrete. Remember, high-strength concrete are to be used for high-rise building. Okay?
Ma'am, nasa BS po yung pinipresent nyo ngayon, ma'am.
Yes, nasa BS na lahat ito.
Ano pong name yan, ma'am? Hinahanap po kasi hindi ko mahanap, ma'am.
Nasa Molecular Materials Part 2. Hindi ba kayo nag-o-open ng na-upload na lesson?
Hindi, ma'am. Nag-open po, ma'am. Kasi hindi pa po nababasa lahat.
Okay? Wait lang, class, ha?
Ma'am, excuse me po.
Yes.
May gagawin
Yes.
po ba, ma'am?
Hindi,
Ay,
tumawag,
okay po.
nag-ano
Thank you
lang
po.
ako, nag-excuse saglit, Mr. Oxenia. Okay, so sorry for the interruption, class. So you should know to differentiate the different types of concrete with their corresponding applications. Okay, the high performance concrete, due to potential economical benefits that can be derived from early strength gain of HPC. It reduces permeability, increase water or abrasion resistance to steel-studded tires, and also improve freeze-thaw durability. So, ang ibig sabihin nito, pag it reduces permeability, the permeability means the seepage of liquids like water. Meaning to say, yung permeability, hindi siya pwedeng mag-absorb ng liquid. Sa increased water or abrasion resistance naman with regards to steel studded tires, okay? And improve freeze dough durability. Ibig sabihin ng freeze dough, yung pagtunaw ng snow, especially in those countries with the winter season. Now, different types of HPC are being considered for pavement repairs. Also, for early opening of traffic, bridge deck overlays, and others. So ito yung gagamitin if, let's say for instance, repairs are undergoing or undergone to pavement or road pavements. Mabilis siyang mag-cure para mabilis gamitin, especially during repairs. It is a durable concrete, which is what you call the fast track concrete. This is the method, this is the technology that is being applied for HPC. A durable concrete called fast track concrete pavement or paving, which is designed to give high strength at very early stage without using special materials or techniques which has been developed. Ito yung tinatawag na FTCP, Fast Track Concrete Paving Technology, which can be used for concrete pavement reconstruction, partial replacement by an inlay of at least one lane, strengthening of existing bituminous. Pag sinabing bituminous, yun yung asphalt overlay or concrete pavements by a concrete overlay, rapid maintenance and reconstruction processes, and airfield pavement. Dito sa airfield pavement, ito yung sa mga um, airport, yung mga road pavement ng airport. You call it airfield pavement. Benefits of applying FTCP is to reduce construction period, early opening of pavement to traffic, and minimizing the use of expensive concrete paving plant. So with regards to high performance concrete, ito yung mga immediate application. Meaning to say, ito yung ginagamit na concrete for those pavement which are to be used immediately. Yung pwedeng gamitin kaagad. Okay? Next is the stamp concrete. Stamp concrete is an architectural concrete which has superior surface finish. Okay? After a concrete floor has been laid, floor hardeners, which can also be pigmented, pwedeng may kulay, are impregnated on the surface, and a mold which may be textured to replicate a stone or brick or even wood, which is stamped on to give an attractive texture surface finish. Ito yung may you can add a decorative what you call component of the concrete. After sufficient hardening, the surface is cleaned and generally sealed to give protection. The wear resistance of stamped concrete is generally excellent and hence found in applications like parking lots, pavements, walkways, and others. So take note, stamped concrete. It is done with a superior surface finish. So we also have what you call the fiber reinforced concrete. Last saglit lang. FRC or fiber reinforced concrete is a concrete containing fibrous material which increases its structural integrity. So the materials that are to be used here are, as fibers are, steel fibers, glass fibers, synthetic fibers, and natural fibers, each of which lend budding properties to the concrete. The amount of fibers added to a concrete mix is ranging from 0.1 to 3%. Take note, 0.1 to 3%. Fiber reinforced concrete is increasingly used on account of the advantages of increased static and dynamic tensile strength, energy absorbing characteristic, and better fatigue strength. Okay, so this is for fiber reinforced concrete. We also have what you call the self-compacting concrete or FCC. Self-consolidating concrete or self-compacting concrete is characterized by a low yield stress, high deformability, and moderate viscosity. So when you say moderate viscosity, this is the consistency of your mix, concrete mix. Gaano kalapot yung concrete mix ninyo. So it depends upon the water that you're going to add, which is necessary to ensure uniform suspension of solid particles during transportation. Okay? Pag sinabing during transportation, like for instance, sa mga concrete truck delivery mix. Okay? Di ba nakikita nyo yung mga truck na carrying mixers? Actually, it is continuously rotating para hindi mag-settle yung mga aggregates and para hindi siya mag-set. So during transportation, placement, and thereafter until the concrete sets. So such concrete can be used for casting heavily reinforced sections, places where there can be no access to vibrators for compaction, and in complex shapes of formwork which may otherwise be impossible to cast, giving a far superior surface than conventional concrete. So, ibig sabihin nung conventional concrete is the usual mix that you follow, like the conventional concrete, yung mga grades niya, if it is M30, M45, or M60. It has been demonstrated that a total sand content of about 50% of the total aggregate is favorable in designing for SCC. So meaning to say 50% of the aggregate is sand. Take note, 50% for SCC. 50% of the total aggregate is favorable in designing SCC, in designing for self-compacting concrete. Now, we also have what you call the dry lean concrete for sub-base. So, dry lean cement concrete or DLC is used as a sub-base for concrete construction. It is a plain concrete with a large ratio of aggregate to cement that is about 15:1. 15 yung aggregate mo, 1 yung cement mo. So, ang laki ng aggregate for a dry lean concrete. The work should not proceed if the temperature rises above 30 degrees Celsius, and in that case, ice may be added, may be applied. The curing of DLC can be done by spraying liquid curing compound or by covering the surface with wet jute bags. During curing, so medyo sensitive itong DLC. You have to consider the temperature, the curing temperature, and also you have to consider the amount of aggregate, which is about 15:1. Malaki masyado yung aggregate mo dito. So if you're going to use 15 bags of aggregate, you have to have 1 bag of cement only. Okay? So,
ma'am, ano ulit yung aggregate, ma'am? Ano yung trabaho niya po, ma'am?
Aggregate is your is your sand and your gravel, that is your aggregate.
Okay po, ma'am.
That will make your concrete strong. Eh kung simento lang, ano mangyayari? Remember, concrete consists of coarse and sand, aggregate, and also cement. Di ba na-take up natin ito during the early discussion of cement and concrete? Okay, we are done with cement and concrete. So any question regarding the topic? We will proceed now to semiconductors.
Yes, ma'am.
Any question?
None po.
Okay, none. Now, you should, you should know how to differentiate the types of concrete and their corresponding applications. So let's proceed now to semiconductors. So semiconductors are materials that essentially can be conditioned to act as good conductors or good insulators, or anything in between. So common elements such as carbon, silicon, and germanium are semiconductors, but silicon is the best and the most widely used semiconductors. So as you can see from the elements that are given, what group of elements are this? In your periodic table, you can check it. What groups of elements are carbon, silicon, and germanium? Which group do they belong to? Check your periodic table. What group of elements are they?
Non-metal, ma'am.
Non-metal? Be specific, Mr. Salvador.
Yes,
Mr.
ma'am.
Marquez. Mr. Borbor.
Group 14, ma'am.
Yeah, but group 14 nga or group 4? Ano sila? May napasali lang si carbon actually, but most of the semiconductors are belonging to what group of elements? Mr. Joseph.
Carbon group po.
Not necessarily. Mr. Villapando.
Ma'am, semi-metals.
Okay, semi-metals or the metalloids. Okay, the metalloids. So take note, anong characteristic ng mga elements belonging to that group? They are under group 4. So what does it mean when they are under group 4? What does it mean when they are under group 4 of the periodic table? No? Hindi nga sila metals eh. Metalloid sila. Nasa group 4. So anong ibig sabihin pag ang element ay nasa group 4? Kalimutan nyo na. What does it mean when an element belongs to group 4? Anong ibig sabihin pag nasa group 4?
May ano sila, ma'am. May
Ngay?
dahil dito. May anong 4 valence electrons, ma'am.
Okay, they have 4 valence electrons. They have 4 valence electrons. So ano yung, bakit very essential yung 4 valence electrons sa mga semiconductors? Okay. Semiconductor valence orbit. The main characteristic of a semiconductor element is that it has 4 electrons in its outer or valence orbit. As you can see, for silicon, it has an atomic number of 14, di ba? So when you distribute the electrons in their valence, in their shells, the outermost has 4 electrons. So 4 valence electrons siya. And bakit naman very essential ang 4 valence electrons for an element to become an insulator? Okay. Let us consider the crystal lattice structure of silicon, as you can see from the figure. The unique capability of semiconductor atoms is their ability to link together to form a physical structure called a crystal lattice. Diba? We took up the crystal lattices of the different metals doon sa molecular materials part 1. Either it's cubical or rhombic. Remember? So the atoms link together with one another, sharing their outer electrons. So as you can see, with regards to the crystal lattice of silicon, the 4 electrons, the 4 valence electron of a single silicon atom will be shared to the neighboring silicon atoms so that the octet rule is satisfied. The stability of the material of the a semiconductor material is attained due to the stability or the sharing of electrons among silicon atoms. Pag sinabing you had a covalent bonding between the atoms, very strong yung covalent bonding. Walang makakadaan, walang makakalabas na electrons. Kaya sila ay semiconductor. Sila ay insulator. Okay? This link is what you call covalent bonds. Remember yung covalent bonding, the mutual sharing of electrons? Okay. So dito, as you can see, very strong yung bonding among atoms, neighboring atoms. This is the 3D crystal lattice structure of silicon. So as you can see, the shape is somewhat cubical. The attachment between the atoms are covalent bonding or covalent bonds. Now, how does it serve as an insulator? If the material is pure semiconductor like silicon, the crystal lattice structure forms an excellent insulator since all the atoms are bound to one another and are not free for current flow kasi nakaband. Remember, electric current is the flow of electrons, di ba? Kaya nga electricity, electric current because it is due to the flow of electrons. Now, pag nakaband na lahat ng electrons, hindi na makaka-flow si electrons, di ba? Kasi very strong yung covalent bonding. So, they are bound to one another, are not free for current flow. So, good insulating semiconductor material is referred to as intrinsic. Intrinsic, that's why they are good insulators. Since the outer valence electrons of each atom are tightly bound together with one another, the electrons are difficult to dislodge for current flow. Hindi pwedeng matanggal yung electron. So silicon in this form is a great insulator. Semiconductor material is often used as an insulator. But the name is semiconductor, di ba? So how can an insulator like silicon serve as a conductor also? Kasi nga semi, di ba? Semiconductor. It can be an insulator, it can be a conductor. Somehow, silicon is a good or a great insulator. How does it become a conductor? By the process of doping. by the process of doping. To make the semiconductor conduct electricity, other atoms called impurities must be added. Now, what are these impurities? Impurities are different elements. This process is called doping. Paano tayo magdo-dope? Para yung yung semiconductor mo maging conductor. From insulator, it will become a conductor. Okay, semiconductors can be conductors. So an impurity or element like arsenic has 5 valence electrons. Check your periodic table. Arsenic is under group 5 of your periodic table, meaning it has 5 valence electrons. Tama? Nakita nyo? So adding arsenic will allow the four of the arsenic valence electrons to bond with the neighboring silicon atoms. The 1 electron left over for each arsenic atom becomes available to conduct current flow. So tignan nyo yung figure. If we dope, magdadagdag tayo ng arsenic sa gitna ng crystal lattice ng silicon. Arsenic will share its 4 valence electrons. May isang sobra na hindi ma-share. Okay? May isang sobra na hindi ma-share. So this extra electron now will serve for current flow. Dito na dadaan yung electric current. Got it?
Ay, ma'am, parang mahina po yung electric current niya, ma'am, kasi isa lang yung ano.
Yeah, i-discuss ko mamaya yun in Mr. Bilipando. Ha? Yung susunod. Kung gaano kadami ang idadagdag mo o gaano ka konti. Okay? Illustration lang muna ito. Sanaya, titignan natin kung marami ba o konti ang idadagdag mo, anong mangyayari. Atom becomes available to conduct current flow. Okay? May excess na electron kasi si arsenic. Yes, Mr. Borbor.
Ma'am, paano po ulit po pag wala pong extra electron?
Walang extra?
Opo.
No. Susunod yun. Okay?
Ma'am.
Susunod naman yun. Masyado kayong advanced, di ba? Susunod na i-discuss natin yon. Ito siya. Before we go to resistance, punta muna tayo doon sa tanong ni Mr. Mauna muna yung tanong ni Mr. Bulbor bago si Mr. Villapando. Another way to dope. You can also dope a semiconductor material with an atom such as boron, which has only 3 valence electrons. Si boron, 3 lang ang valence electrons niya. So, 3 lang yung ma-share niyang electron. Kulang, di ba? Dapat 4 or dapat sobra para maging conductor. Pag 4, insulator. Pag sumobra, conductor. Paano pag kulang? Si boron, it has 3 valence electrons. So, the 3 electrons in the outer orbit do form covalent bonds with its neighboring semiconductor atoms as before. But 1 atom is missing from the bond, or 1 electron, this should be electron. But 1 electron is missing from the bond, kulang ng isang electron. This place where a 4th electron should be is referred to as a hole, may butas. Kita nyo siya, ito yon. Huwag niyong pansinin yung extra dito kasi yun yung sa arsenic kanina. May butas dito kasi kulang ng electron na na-share sa neighboring silicon. The hole assumes this place where a 4th electron should be is referred to as a hole. The hole assumes a positive charge, so it can attract electrons from some other source. Okay? It can attract electrons from some other source. Holes become a type of current carrier like the electron to support current flow. Got it? So, naging positive yung hole mo, di ba? Pag positive, nakaka-attract ng negative. So, ito na yung passage ng electric current. Did I answer your question, Mr. Borbor?
No. Yes po.
Okay. To answer the question of Mr. Villapando, resistance effects of doping. If you use lots of arsenic atoms for doping, there will be lots of extra electrons. So the resistance of the material will be low and current will flow freely. If you use only a few boron atoms, there will be fewer free electrons, so the resistance will be high and less current will flow. By controlling the doping amount, virtually any resistance can be achieved. Okay, got it, Mr. Villapando? Nakuha mo yung point?
Yes po, ma'am.
So if you control the doping amount, virtually any resistance can be achieved. By the way, class, with regards to electric current or electricity, which is the flow of electrons, sa bahay meron tayong circuit, di ba? Circuit diagram. May circuit diagram tayo dito how electricity or the connections of electric current are connected. Ano yung mga resistance natin dito sa bahay nyo? What are considered to be your resistors or your resistance that controls the flow of current? Sila yung pinaka-doping natin. Mr. Estomo.
Yung mga switch po ba?
Yung mga?
Switch po.
Anong sheets?
Yung, ma'am, switch po, switch.
Switch.
Opo.
Switch kasi is yun yung nag-o-off and on ng flow ng electric current. What I'm referring to are the resistors. The resistors. The resistance. Yung switch yung nagpapatigil. Okay? Halimbawa, in-on mo yung in-on mo yung ilaw, of course, there is a flow of electric current there. Pag in-off mo siya, wala nang flow ng electric current. Pero ano yung mga resistance that resist? In-on mo yung switch or pag in-on mo yung switch, di ba, there is flow already. Ano yung mga resistors? Mr. Romano. No.
Ako ma'am, try ma'am.
Yes, Mr. Salvador.
Yung ma'am, sa mga charger po ma'am.
Charger.
Yes ma'am.
Ano pa? Ano yung mga common? Ano yung mga common?
Ma'am, try lang. Copper, ma'am, copper.
Copper, conductor yun ng electricity. Doon nagpo-flow yung electrons mo eh. Ano?
Ako po, ma'am, try po ulit, ma'am.
Ano?
Ano po, yung mga heater po, ma'am. Heater, po
Heater,
ng
ano
tubig.
pa?
Ano po?
Ano yan? Ano yan? Yung? Insulator yun. Insulator yun eh, yung coating. Insulator yun. Para hindi ka, para pag ginawakan mo yung wire, hindi ka makukuryente. Nagsabi na nga si Mr. Estomo eh.
Ma'am, yung sa rice cooker, ma'am. Kasama ba yun, ma'am?
Yeah, appliances are the resistors to the flow of electric current. Take note of that. Yun yung mga gumagamit to have power are the resistors. Sila yung gumagamit. The appliances are the resistances to the flow of electric current. Got it? Got it, class?
Yes po, ma'am.
Yes po, ma'am.
Okay, we will take that up pag meron ka na kayong applied physics. You will be studying the how much current is being absorbed by a certain appliance. What will be the resistance? Okay, so let's move on. Types of semiconductor materials. The silicon dope with extra electrons is called the N-type semiconductor. N stands for negative, which is the charge of an electron. So ito yung ginagamitan natin ng silicon. Now, silicon dope with material missing electrons that produce locations, holes, is called the P-type semiconductor. Yun yung boron. Boron ang ginagamit dito pang dope. P is for positive, which is the charge of a hole. Okay, got it? Now, the current flow in N-type semiconductors. The DC voltage, DC stands for direct circuit, has a positive terminal that attracts the free electrons in the semiconductor and pulls them away from their atoms, leaving the atoms charged positively. Electrons from the negative terminal, so yung positive terminal ng source mo, battery or other DC voltage source. Positive, this is the negative terminal. Electrons from the negative terminal of the supply enter the semiconductor material. Ito yung semiconductor material mo, and are attracted by the positive charge of the atoms, missing one of their electrons. So the current flows from the positive terminal to the negative terminal. So it's the opposite naman dito sa P-type. So if the flow of electrons for the N-type is clockwise, okay, clockwise, pag ganon, direction of electron flow from your semiconductor is clockwise for the N-type. For the P-type, okay, it's the opposite naman. The movement of the electrons from your semiconductor is counterclockwise. Ito siya, counterclockwise. But of course, the direction of pole flow is always this way pa rin. Electrons from the negative supply terminal are attracted to the positive holes and fill them. The positive terminal of the supply pulls the electrons from the holes, leaving the holes to attract more electrons. Current flows from the negative terminal to the positive terminal. Inside the semiconductor, current flow is actually by the movement of the holes from positive to negative. So those are the current flow for the N-type and the P-type semiconductors. Okay? Next. What are the applications, or where can we use this semiconductors? We have for microprocessors, capacitors, transistors, and also for LED. We have what you call LED lights or LED television. Ano ang LED? Anong ibig sabihin ng LED?
Light emitting diode.
Mr. Catley.
Ma'am, light emitting diode po.
Okay, light emitting diode. Bago magkaroon ng LED, meron din tayong LCD. Anong ibig sabihin ng LCD? Diba, yung mga first, mga lumabas na unang ng TV, what is LCD? Mr. Coronel. Mr. Coronel, ano ang LCD?
Marinig po.
Yes.
Ma'am, less common din namin nito.
Sa electronics tayo, Mr. Coronel. Mayroon kang LED, light emitting diode. Ano naman yung LCD? Like yung TV mo, LED, pero bago lumabas ang LED, meron din tinatawag ng LCD.
Ako ma'am, Marquez Mabawi po ako.
Meron ka na eh. Yung iba naman.
Ma'am, Carrion po. Ma'am, Carrion.
O, Mr. Carrion.
Ano po, ma'am? Liquid crystal display
Okay,
po.
liquid crystal display. Bago magkaroon ng liquid crystal display, sa mga display techniques natin, CRT muna. Anong ibig sabihin ng CRT? Yung monitor natin sa computers, yung screen natin sa TV, yung mga pinakauna, they are actually mga bulky, tapos concave yung shape ng display. Anong tawag doon?
Ako po ulit, ma'am.
Saglit, pagbigyan natin yung iba, Mr. Carrion, ha? Sino to? Mr. Ibatuan. Mr. Ibatuan. Ano ang
Opo, ma'am.
CRT? Mhm.
CRT po. Lang po, ma'am.
Ha?
Cathode ray tube po,
Okay,
ma'am.
cathode ray tube. Cathode ray tube. Okay, CRT. Okay, so ito yung mga applications ng mga semiconductors. Now, in your periodic table, the yellow ones are considered to be a component of semiconductors, but the most common or the widely used and the best used semiconductor is silicon. Okay? Now, let us take the conductiveness of materials. Sa insulators, the conductivity for fused silica, diamond, and glass is about 10 to the minus 20 to 10 to the negative 8 per ohm per centimeter. Per ohm per centimeter. Ohm is actually a unit for resistance. Ohm is actually a unit for resistance. But in this case, pag dinagdagan mo per ohm per centimeter, it becomes conductivity unit. Sa semiconductors, it will be 10 to the negative 4 to 10 raised to 0. And for metals, which are the best conductor of electricity, we have 10 to the 4 to 10 to the 8 per ohm per centimeter.
Ma'am, nagpe-present kayo, ma'am?
Yes.
Ma'am, wala po sa akin yung na lumalabas.
Wala ba lahat sa
Meron po,
inyo?
ma'am.
Meron po sa akin.
Meron po.
Baka nagdalag sa'yo, Ken.
Baka may problem sa connection mo, Mr. Villapando.
Reconnect ako, ma'am.
Nakikita mo naman ito sa sa uploaded PPT sa BS, ha? Sa the range of conductiveness. Okay, so ano yung mga semiconductors? We have silicon, germanium, silver, etc. Now, semiconductors have special electronic properties which allow them to be insulating or conducting depending on their composition. Okay? So any question about semiconductors? That's the last molecular material that we will be taking under molecular materials part 2. Okay, that ends the presentation for molecular materials part 2. Are there any questions?
Ma'am, gagawa ba kami yan, ma'am? Yung nasa nakapresent, ma'am.
Supposedly kung tayo ay face-to-face, pero hindi. Sa physics nyo siguro, pag nag-face-to-face na, sa applied physics nyo, pwede kayong gumawa as project. Sa physics. Pero we just wait if magiging face-to-face na. Pag second year na kayo. Ha? Kasi next semester is in. Okay?
Wala na pong chemistry next sem, ma'am.
Wala na. Gusto mo
Ulo. Paborito
Gusto
ko
mo
to,
pa?
ma'am. Nabagsak lang po ako.
Paborito mo pero bagsak ka
Hindi
pa,
ko
no
alam,
yun?
ma'am. Basta, ma'am, paborito ko po to.
Pero
Opo,
bumabagsak
ma'am.
ka
Di lang po ako
naman.
gusto ng chemistry, ma'am.
Okay. O
Ma'am,
gusto mo, um, yeah, kayo ay mayroong term 1 at saka term 2, I think. Thermodynamics part 1 and thermodynamics 2. Yeah, I used to teach thermo, pero iba na yung nagtuturo ngayon. I
ma'am,
used to teach thermo.
ma'am, ano po maging replacement sa chemistry next sem?
Physics na.
Physics po, okay po.
Engineering at physics for engineers kayo next semester. Okay, so Mr. Marquez, gusto mong ulit mag-take ng chemistry?
Hindi, ma'am. Ayoko, ma'am. Ayoko po mag-repeat, ma'am.
Akala ko gusto
Okay na
mo.
po ako, ma'am.
Pwede naman ikuhanin sa summer kung hindi offered
Hindi,
din sa...
ma'am. Huwag na. Pass po ako, ma'am.
Kasi sabi mo bumabagsak ka eh.
Hindi,
Gusto mo
ma'am.
pa yan ngayon.
Bawi na, ma'am. Bawi, ma'am. Bawi po. Late game po. Late game.
Okay. So mag-aral para hindi bumagsak. Okay?
Yes, ma'am.
Okay. So pasok na tayo sa Energy and Thermodynamics Part 1. Tapos na tayo dito. Papasok na tayo sa bagong topic. Break tayo mamayang 12, ha? To 15 minutes lunch first.
Thank you po.
Okay, are you with me now?
Yes.
Yes po, ma'am.
Saglit. Okay, so with respect to, I mean, in relation to what was discussed about system and surroundings, a while